Let's find the force on this circular window in a pool. This is a complicated one, so let's go slow. The pool is 8 meters deep. The window is 2 meters in radius, so 4 meters in diameter. The integral that we use for force is ADD area. Acceleration, density, distance or depth. And if we have a representative element here, so that's right there, there's our representative element. The distance that element is below the surface of the water is going to be 8 minus y. Then we have area. This is the area of the horizontal element. And we're imagining it going all the way across. And so what we need to do is find the equation of this right side of the circle, isolate x, and then double it. And that's what I've done down here. So the equation of the circle is x squared plus y minus 2 quantity squared equals 4. And then I have come down and I've isolated the x and I've simplified, I've squared that out and simplified. So that right there is going to measure the distance horizontally from the y-axis to the right over to this red curve. So it's going to measure that distance right there. That's what this x is measuring. If we want to go all the way across the circle, we need to double it, which is what that does right there. So this right here is the width all the way across the circle. Now this integral is going to be a little messy. I'm going to do a couple of things here. So first thing I'm going to do is just combine the 9800 right here and put it out in front. And this 2, I'm going to distribute into this quantity to its left. Why am I going to do that? Well, this integral looks like it wants to be solved with substitution. And if we were going to solve it with substitution, we would let u be whatever's under the integral. And this is going to give us negative 2y plus 4 multiplied by dy. Now that's not exactly what we have here. This expression to the left there is 16 minus 2y. But the negative 2y matches. And so I'm going to use a clever technique here and write the force as 9800. And this integral is going to be separated into 2. We are going to rewrite the 16 as follows. We are going to say, okay, well, if we want to match this negative 2y plus 4, I'm going to write this as 12 plus 4 minus 2y multiplied by the square root of negative y squared plus 4y. And then we are going to distribute the square root to those 2 quantities. So we will have 9800, big bracket. We are going to have the integral that is going to be 12 integral 0 to 4 times the square of the square root dy plus the integral from 0 to 4 of 4 minus 2y multiplied by the square root. So we distributed to each of those pink terms. Let's focus on the u substitution part for a minute. Let's just leave this first part alone. So we're going to leave this as is. Note that this integral is not computable by normal means. We are going to need geometry for that one. But let's first focus over here. So we are letting u be the negative y squared plus 4y, and then du is going to match exactly what's on the outside. So this is going to be the square root of u times du. Now let's get the u limits, and here we get something very interesting. So first we have a y limit of 0, and we plug that y limit of 0 up here, and if y is 0, we see that u is also 0. Now we're going to plug in the the y limit of 4 to figure out what the corresponding u limit is. And when we plug in that up to here, plug in 4, we're going to get negative 16 plus 16, which is 0. And an integral from 0 to 0 is 0. So all of this turns into 0. That leaves us with this geometric piece over here. We are going to take the 9800 and we are going to multiply that by 12. So bring that to the front, and we're going to have 117,600. And next we have to interpret this integral here. So the interpretation of this integral is done geometrically. That function there, x equals the square root quantity there, we've already done that here. We've already done that right here. Okay, so that is the right half of the circle up here. So that function is the right half of the circle, and we are going to integrate from 0 to 4. 0 to 4 is along this diameter. So this integral represents the area beneath that curve, which when we're dealing with functions of y, it means the area between the curve and the y-axis. And 0 to 4 is that entire diameter there, so that integral is representing half the area of a circle of radius 2. So a circle of radius 2 is pi times the radius squared, and then to get half of that, we will divide by 2. And so this will end up being 117,600 multiplied by 2 pi. So all we have to do is multiply by 2, and we will get 235,200 times pi. And the units that we have here, we are dealing with force, so the units are going to be newtons.